And we're back. Woo. Okay, cool. So, today we're working on colours. What we have at the moment is the ability to drop these. They'll nicely drop on top of each other. They won't let you go off the end. They keep their grid. The only problem is you can kind of blat into the side of an existing column, so we just need to stop that before we start doing any of the mechanics. So yeah, this is the game class. There's not a lot in it yet. Here is where we check for left and right keys, and we're basically saying if you want to go right, you're fine as long as you're not near the right hand side of the screen. So we need to be a bit cleverer here. We need to check if we need to check the board. So we need to say something like or, and we need like a board clear. Board dot is clear, and then give it an X and Y position, I guess. So it'll be row column, so the row column will be Y divided by the block size. Column will be X divided by the block size. And that's actually checking where we are, so we want to check one to the right of us, so we need to add 1 to that. Okay, and if both of those things are true, we can move right. We don't actually have an isClear function yet, so this is our board. And we do have a get. And that gets as if there's anything there. So it is clear. Just return get. So if that's null, if it's empty, it's clear. This is only checking, you see, this is only checking the top square. This thing is 3 squares deep. So what I could do is add a number on the end of there. Depth. And then we can do for plus, we'll call it Y because we're basically going down on the Y axis. We can say get it doesn't equal to false because there's something there. If we've checked all 3 squares, we'll return true. Just need to add Y onto there. So we check for row plus 0, row plus 1 and row plus 2. If any of them don't equal null, then it's not clear. So that does. Let's build a tower. Okay, so it shouldn't let me go across that tower. Oh, it did. Oh, I only did it from the right. So, yeah, let's say that was working. Cool. Okay, so I need to do it from the left as well. Wow, too many windows open. Go away, go away, go away. Keep that up. Okay, so the board bit works. Let's do that. Okay, and if we're hitting the left key, then we need to make sure that board is clear. Just going to nick that bit of code, and it will be -1. So we're looking to the left of where we are. Okay. There we go. So, one of the things that's bugging me is that it seems to leave a gap in between. I don't know why. Very strange. So, where do we check that we've hit? Here. We check that we've hit. We're going to hit something. We set. And then we drop another piece. I might just stop that there and just see where they are when we get to them. Okay, that's the first drop. That hit the bottom. That's the second drop. Now when this hits the top here, boom, okay, so where is everything? The group is at 400, 696. I'm thinking that should be 700. So we've detected a collision just a little too early, I think. So this hits here. Let's put a breakpoint in there. again. Okay. So, boom, there. Okay. So the rectangle is at 696,400. So we can go back into this thing and see what it did. So we're going through the child blocks. There are 3 of them. Get the position of the child block, which is currently 400,696. Yep. We're going to move it. So we'll be at 400, 700 on the next frame. This is like a look ahead. Get the bounding box of yeah, that looks okay. So from 700 to 749, and then we're going to hit test with that box. So we're going through the board, looking at the blocks that are already in there. So what's this one? This one is a, oh crikey. That's a weird place to be. That shouldn't be there. Yeah, so it looks like when we hit the bottom, we're stopping a little early. Where's that block? That block is at 848. It should be 850, surely. Yeah, it will be 850, then 900, then 950, because the whole thing is 1,000 deep. Okay, so the problem is hitting the bottom of the world. Where's the code that does that? This is here. So if we hit the bottom, okay, let's stop it there and see what it does. Okay, so where are we? We are currently 400,848, see? This is interesting. What's the speed of this thing? Yeah, the speed is 4. Okay, so 4 means we're going to jump over 50. 50 pixel blocks. Haha. Okay, what I'm going to do, just to cheat that, is set the speed to 5. Is that the speed there? There is the speed. Let's have a... bring that out to the top. So if we fall at 5, it'll go faster, but it should hit the bottom. There we go, all nicely. Okay, ooh, no, still doesn't. It's just letting me, yeah, okay. Collision detection isn't working for the top. What obviously not checking the right blocks. Strictly speaking, if 3 blocks are halfway between one block and the next, we should be checking 4. It could potentially hit 4 blocks. Feeling we should be starting 1 up. Nope. Nope, I can still break that. Annoying. Okay. Stick a breakpoint in there for when we hit the right mouse, hit the right key. So, there. Okay, so we're looking at row 13, column 7, depth 4. Whereabouts are we? We're on column 6. Column 6, and we're halfway down 14. So we're going to check 13-7, 14-7, 15-7, and 16-7. What have we actually got? We've got 17, 18, and 19. And we're checking 13, 14, 15, and 16. Okay, so we're too low, aren't we? We're checking too low. Yeah, that -1 was nonsense. Okay. Okay, that's better. I can still nip in on top, but not once I've gone past it. That's it. Beautiful. Okay. Okay, cool. Right. So the next thing we're going to do is allow ourselves to rotate the colours in our falling block. So let's make that go away in our update function. if somebody hits the control, key button, key, we need to do is we need to remove the top block from the falling group and then add it back in. Okay, first of all we need to get the top block. Should we remove the bottom one? Let's remove the bottom one and then push it. No, you know, let's take the top one first. So shapes is what I'm falling. Get the top one. Remove it. And then add it back to the end. What does that do? Yeah, that's fine. Will that actually do anything? No. Okay, we've reordered them in the list, but we haven't actually changed their positions. Good job. So we can just go down the children of yeah, and we can set position to be the X will be the same and the Y of the, so this is the current position of the top piece. I don't want to include the parent, I just want the relative position within the group. Okay then, so the top one's going to be the top one, and then we're going to add on block height. So that should reposition the three pieces. Woo! Fortunately for me, that's counterintuitive. I'd prefer it to rotate downwards. It just looks, don't feel like it's rotating, even though it is. I think we do need to rotate downwards. Okay, so children 2. Fortunately means we need to insert it at the beginning, which I don't think we have a function to do. Would you insert something in a vector? Gone. Stood vector. Set. You give it an iterator and a value, so we want to put it at the beginning. So that implies at the beginning for now. Okay. So we remove the one from the end, stick it in the beginning. Ah, no, that's not going to work. Because we need to offset the positions from the one at the top. In fact, I know what the positions are. Positions are not... The relative positions are always the same. They're always 0. And it's only the group that moves. The positions of the blocks within the group stay the same. So I don't really need to do that. Okay, let's try that. Yay. So now I need some more colours. Because red, green and blue is pretty tedious. Let's have... Red. Green. Blue. Whatever that is. Inspect. Apparently I can. Okay, so when we do a drop, we have some hard-coded colours over here. So we're going to get a random colour. So we want a random index from index. I think I wrote a. I've got a. Sure, I've got a random function somewhere. D word, D word. So for a random colour, and do that. There is a random colour. So if I stick that in there, there. Is that going to work? Oopsie. We went off the end of the colour vector, didn't we? So colours available is 7. Did it actually give me 7? Okay, that's the high value. So don't actually want to go up to 7, I want to go up to 0 to 6. Okay, cool. So the whole point of the game is to make lines. I haven't really thought this bit through, but lines of 3, I guess, would disappear and the rest would drop. So before we drop, so we add the blocks to the engine, remove them from the group. Where did we add them to the board? Here, okay, under there. I mean, to be fair, we're doing the same thing here and here. So we might as well do that in drop. That's identical, isn't it? So in drop, make sure that doesn't crash it. Okay, that's cool. So I'm just going to put something like resolve. So in the board. Check for lines. So I'm just going to brute force this for now. So we'll go for row is not less than. So we'll go along the rows. How many rows are there? 20, aren't there? How many columns we got? Forgotten. 16. Do this square is if there is a square, is there a get color? There is a get color. So CR this equals CR last. So we've got 2 in a line. There isn't. Gotta go back to 0. Okay, so that's the number of matches we've got so far. No match. We got a match. If they're different, we're going to have to say but no match. Yeah, at the bottom of all that. We've managed to get to 2. We've got 3 in a line. In which case we want to remove the last 3 squares. Column. So we're going across the column. So we want to remove square. The one we're on. Remove those 3 squares. So this is only going to do horizontal lines at the moment. So now I need a remove square. So the easy bit is removing the square from the board. So we should probably delete it first. And then we should set to null. And then, well, let's just leave it like that. That will black them all out, hopefully, but not. We need to make the ones on top fall down, I guess. Okay, so 3 blues. Boom. Interesting. I'm assuming it removed something from the board and then the next frame crashed because the board was in a mess. Yeah, okay, we shouldn't have set it to null. We should have just totally removed it from the board. So that it's not a good idea. We need to just totally. So it's a map of a map, which is meh. Just in case it's not there. And then we need to do, we just need to erase that. Dot second. Boom. Okay, cool. It disappeared. So that's cool. So now I need to make these 3 drop. So we're looking for squares. Of both us. So we'll work up going up the rows. And if we can try and get the square above us. So sq equals get. So if there's a square there, we need to remove it from where it is and reinsert it. Okay, I'm just going to call this remove square and drop. Just removes the square because that'll be a useful. Which just does that. all that does is remove it from the board. So here we can remove the square from. It would be nice actually if this thing returned the square we've just removed, actually. Let's do that. Because that's a useful thing to have. It's not a square, it's a shape. bit dot second dot. Okay, let's just get the shape that we want to return before we actually erase it. What is this thing? Yep. Return it. Okay, so that will return the square and then remove it from the board. So we can just delete it. So that deletes the original one. Oh, we've already got it. We've got it here. Okay. It's under there anyway. Okay, so now we need to set the row we've just vacated with square. Start at the row above. I want to make sure that that's always greater than or equal to 0, so still within the board. There we go. Numbers, 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 numbers. Okay, 3 greens. Yes, 3 greens. See, broke the board again. Oh dear. Okay, not a problem. We just need to see what it's doing. I think will be the easiest. Dark blues maybe. Light blues. Reds. Reds. Bulk. Oh, there's no squares on top of that. Never mind. So let's remove the square. No square. No square. Square. I mean, to be fair, if we find a gap, then there's not going to be any more. Let's change this code to if there isn't a square there, then might as well just leave. There's not that many gaps. Okay, done that again. That's what we're trying to do. Yeah, I'm trying to debug the 3 match. Great. There. Okay, so we've got 3 whites with 1 on top of each. So the square I've just got should have a colour of, yeah, big number. That's white. Okay. So we need to get the square above it. That's cool. There is one. We need to remove it. So ret is B3510 and square is B3510. Yeah, they agree. Let's just make sure it's on the board. There are 3 things on. And then we're setting 17, 11, the current square. And then we're going to break. That looks fine. Really doesn't like it though. Ah, we've deleted a block but not removed it from the engine. It's trying to draw the block that we deleted here. So we need to remove that from the engine. Annoyingly, we're not in the engine anymore. We're in the board. So we can either return a little list of all the squares we've removed back to the engine and let it remove them. Wonders of scope. Let's return, instead of deleting it, let's just return the shape that we removed. Okay, so I haven't deleted it yet, we've only removed it. So in our resolve function, we could pass it a vector of shapes. And then we could just stick these in the vector. So no, we need one of them. So then our resolve function, which we call from the engine, pass that in there. What's wrong with that? Okay. And then we can just iterate through deleted shapes, saying remove it. Remove shape will actually delete it for us as well, won't it? It will. Okay. So let the engine remove them. Try that. Well, it's kind of working. Doing something. Not quite there. Just start again. It removed 2 of them. Oh, that's interesting. Just remembered the old board. So, in D-Init, we need to clear the board. We need to do that. The engine will delete them. Okay, I'm just going to remove that. We're just going to go mboard.clear. That's a map of maps. It's a map of maps, of pointers. Yeah, we don't need to do it. They're just there. We just clear the board. This is hard. It's too fast. I need to address the speed issues. Okay, what happened there? Resolve. Oops. Let's check the resolve function. I'm assuming this rather clunky bit of code works. Let's see. It's definitely deleting something. Okay, remove square and drop. 17.8. So that should give me 3, all of the same colour. 65535, 65535, 65535, yeah. It didn't, oh. It was still drawing the last one. So 2 of them disappeared, but the 3rd one didn't. 18.7. Remove square at 18.7. Get the square at 17.7. There is one. Remove the square at 17.7 and set it into 18.7. What does set do? Yep. Get the square at 16.7. There isn't one. And return that original square, the one we deleted. Removed. And stick that on the end of delete shapes. Okay. 6. 18.6. Seems fine. And 18.5. Okay, so we have 3 deleted shapes. I'm going to remove that shape. How many shapes have we got? 7. That's interesting. We couldn't remove it. But we did find the second one. And we did find the third one. But we can only find 2 of the 3 ships in the engine. That's weird. Add the blocks to the board. Add the blocks to the engine. Okay. This is the issue here, isn't it? I didn't need any of that. Okay, let's... No, these are different. Add the blocks to the engine. Yeah, no, that's... Yeah, of course, it's the one in the piece. One in the piece has just disappeared. So it's still in the board. Okay, we should only cue the shape. That hasn't been deleted. Yeah. Because one of the 3 in the group might have been deleted. So we just need to look in deleted shapes. So we'll look from the beginning to the look So if we can't find it, we can queue it. Queuing up shapes that we've removed. And dropped. They definitely haven't dropped. Okay. Ah, no, they have dropped in the board, but they haven't dropped in the world. It's still drawing them in the same place because the position. So we need to SQ set was. Just need to move it down a block width. Well, we can do an offset pause. Offset pause. So block width, size. Can I do that? Should be static anyway. And then I can't initialize them. Oh, for goodness sake. That's annoying. Bring back hash defines. I think I might. Sorry, bot. Certainly doesn't. Okay, I'm not proud of that. Oh yeah. That worked. Hey. Oh man. Okay. It's really difficult. Verticals. Yeah, okay. Let's do the verticals. Oh. We do the columns followed by the rows. Green. Not quite. Something to do with the ordering? If you drop, no, you want to drop the top one first. No, you don't. Just the ordering. Drop the bottom one first. No, the top one first. Drop, and the next one drop, and then the one underneath drop. Because if you drop the bottom one, drop, and then jump up one, you've missed one. That's it. No, I'm starting to think. Oh, that's interesting. We had 4 there and it only took 3. You've got to take them all. So, we could do this a little different. Have a vector. Let's just save that bit of colour. Instead of a match count, let's have a shapes matched. If square, for auto m in matched, if m dot get color doesn't equal CR this, so this is our color. Make sure that everything in matched is the same color as we are. If not, then just add ourselves to it. Okay. This would be easy to test if we did it with this one, actually. Let's do it with this one. A set of matcheds. We add ourselves to the matched. And then just check they're all the same colour. If they're not, you clear them. So let's have a check. Matched. Let's say matched. Okay, so if matched dot length, nope, size greater than, and we've put ourselves in, but we might be the one that broke the chain, so it has to be greater than 3. So we'll go through matched and the delete. Okay, I've got to pass delete shapes through there as well. Check matched. Check matched. So I think we just need to remove matched dots. Just want to remove the one at the end. Okay. Remove last element of stud vector. Pop back. Check matched. I think we need to do that in there. So here we didn't actually push anything on it, did we? That's better. Try an engineer of 4. Ha! Yeah, I didn't do vertical, did I? There's a 4. Okay, that looks like it works. So I need to do that. Vertically. Okay, horizontal definitely works. Oh, didn't work. Come on, give me a double. There's a double. That didn't work either. So the 5 didn't work, and the vertical 4 didn't work. Resolve horizontally. Oh, yeah, no, I'll tell you what, the 5 didn't work because we got to the end of the row. So I need to do one in there as well. There's no point clearing it. That's why the 5 didn't work, yeah. Vertical 4 only took 3. Could be the same problem. Don't know why it would only take 3 though. Push back. Pushed it on the back. I wonder if it's the order in which we're removing them. Yeah, I think it probably is the order we're removing them. This one out. Kind of want to iterate that backwards. How do we do that? What? Yeah. So that's a reverse. So I've got a clunky reverse iterator. And I think it's something like that. It's good, tester. Oh, 3. You get 3 for free. Brilliant. That's just rubbish. That's no good. Wait, what? Something just disappeared and it shouldn't have. No, it didn't. Either did that. No, something going wrong here. Horizontal still work. Only verticals. Let's go. It's 4. Brilliant. So matched should equal 4. It only equals 3. So that's wrong for a star. row, column. So we're on column 9, row 19. That's the square. Okay, let's not do anything here. I can force this to skip that. And then let's go back to here. So we'll start again at row 0. It's 1. Okay, so we need to keep going until we hit that. So on row 14, we get whatever that is. That's white. Okay, so we stick that in matched. Next one we get is red and blue, purple, yes. So I've got two things in here. Got a white and the purple. Ah. You remove the square that broke the chain, but then you're not checking it for next time. Ha. Yeah. We've skipped over. We need to put that back. In order to check it for next time. It's probably going to crash. Maybe not. There we go. There's a 4. That's it. Nailed it. Okay, so I have mechanics going. Now it just needs to be a little more interesting. Oh. Same problem I'm guessing with the horizontal, yeah. So what was it? It was in between the clear and the break. You gotta push that back in. Okay, I've kind of done up everything I wanted to do today. I could remove a lot of these warnings. Convert from size T to D word. That's a D word. That's a size T. Build that. Okay, that's better. Okay, cool. I need to think more about what to do with this game next. There's definitely something there. Thanks for watching.